Welcome to the Zelfaldar Assembly Language Programming Tutorial Series, Episode 3. In Episode 2, I covered creating the scrolling water effect using the Commodore 64 program interrupt. In today's episode, I cover creating a text window and printing text within the confines of that window. Before getting started, I wanted to point out that I did a little bit of research looking for built-in kernel routines that would handle window scrolling and the like, similar to how it could be done on the Commodore 128 with the basic window command. Although I came up empty, I did come across a few websites I thought were interesting, including these two. This is the Commodore 64 Screen Functions webpage that I came across, and it has a lot of information on it. It's similar to the one that has the memory map. It's the same website, but a different web page that has the memory map, the entire memory map of the Commodore 64. So I've used a few of these kernel routines coming up in the upcoming segments. And then the other webpage that I found that I randomly came across was this fully commented Commodore 64 ROM disassembly. Now, I didn't end up using anything out of this, but I thought it was very interesting because it has some of the basic routines broken down on what they look like in assembly language. And let me show some examples. Like this is a list command, the for command, and stuff like that. So I thought this was a really interesting webpage, and I'll have the links in the notes at the bottom. So now let's jump into this episode's first segment, and I hope you enjoy. Well, in the previous segment, we sort of left off with a screen design here, and this is what I came up with. This is a temporary working idea. And I was thinking this could be the window where you move the game map, you have your stats over here, and then you do your commands down here. And then that got me thinking, how exactly do you do the commands down here? How do you just go about displaying them and scrolling this area down here? And of course there's multiple ways of doing that, but I looked on the internet and I looked on the Commodore 64's memory map, and I couldn't find any built-in windowing schemes or anything like that where it sets a window size and only lets content scroll within that window. So what I did was I came up with this short program right here that we're looking at, and let me show you what it does first, and then I'll explain how it does it. Okay, so each time you run the program, you see this little area right here, it scrolls it up. So you define a window size, you define the position, and it just scrolls it up. And I figured that would be the first thing you would need. You would need to be able to scroll up what's in here and then print your text right here. So the first part of it was to scroll up. So each line has to scroll up one position, and then the bottom line is blanked out. And that's what this is doing here. So there's two loops here. The first one here is to load the line below the first line, store it to the top line, and loop until the width of that line. And then the second loop is to go down one and then repeat the process. Wash, rinse, and repeat until you get to the maximum height of the window. And these positions here are set up from this little macro. What it's doing is an LDA, comma Y, STA right here. LDA, STA, LDA, STA. So it's loading the high byte right here. It's loading the high byte off of this array down here. And then it's storing it in input plus 2. Then it's loading the low byte off of the screen position and storing it in input plus 1. So it's getting the vertical position using that. So I'm doing that 2 times, once for the input. So I'm loading the line below, storing it in the line above. And then when you get down to the bottom, when you're done with shifting everything up, that bottom row is duplicated because you've copied the bottom row. So what you have to do is decrease the value of y by 1 after this loop is finished looping to the bottom, and then blank out that bottom line. And so that's what this little loop here does. So this loop runs through and it blanks out the bottom line. And if I comment it out, I could show what that does, or if I just do an RTS. Oops. If you don't have this part, watch what happens. See how that second to last line is duplicated and it pushes it up. But what I like about this little program is that it allows you, what we have down here is an X position of the window, a Y position of the window on the screen, a width, a height, and then I have a variable here called max width. And max width is set up by adding the window X position plus the width. So the position of your X position on the screen plus the width of the window, and that's the max width. And then similarly, you have to set up your max height. You take your Y position of the window, the height, add in the height, and that becomes your max height. So that way the loop knows when to terminate. It knows to only go to the maximum width or to the maximum height. So that's what that does without it. Now, there's the idea crossed my mind that I already have written a window scrolling subroutine in here. Why not just use it? And I certainly could do that. It's pretty efficient, but then I'm going in and tweaking it, and I really didn't want to. I just thought, since it's such a minimalist piece of code, I thought it would be easier, or better in this case, less hassle, to just rewrite that part of it. Now, something I was tinkering with was the idea of that bottom line that's being wiped out. That can be completely erased if we do one thing, if we just blank it out as we go. It's less efficient to do it that way. But for example, let's say we leave this RTS in here so we don't execute this code down here. And instead we come up here and we load a space character, which is a 32 or a hex 20. And we give it a label here like last line. And all we have to do is when we're setting up these two rows, we got to set up last line also. So we'll just copy this guy. And instead of using @input2, you put last line. And that should set up these variables right here to blank it out as we go and effectively eliminate this code right here. However, this is less efficient. Let's run it to see what we get, if it works. And you see, works just fine. Blanks out that last line. So you kind of have to wrestle that idea of, should I use a more efficient a faster routine or a more succinct type of code structure, and I'm going to comment out that part and keep it this way for now. Now, looking at the Commodore 64 kernel, and in here I was noticing that there's a way to scroll certain aspects of the screen by calling the kernel routines. Like, for example, this one inserts a line before the current line and scrolls the lower part of the screen downwards. And then this one scrolls the complete screen upwards and uses the following registers, A, X, and Y. So check this out. E8, EA. Let's test that out. Let's do a test routine. JSR. Oops. E8, EA. Was that it? E8, EA. Return back. See what that does. See that? Shifts the screen up. And let's see if anything shows up at the bottom there. It puts a blank at the bottom as it shifts. So look, with just one sub call, you could be shifting the whole screen up. So the equivalent, the equivalent way to do that with my little program here is to just make the width 40, the height 25, and make the window start X and Y positions 0, and then run it. And let's see if we put some letters down here. Oh, I'm not sure how to turn insert on my keyboard to get that last character. But I'm going to shift it eventually. Okay. See that? That's a quick program to scroll the screen in one line of code, the entire screen. I wish it was more configurable to an X or Y position, similar to what I'm doing. I wouldn't have had to sort of reinvent the wheel. Now, I'm not done here. My ultimate goal would be, the ultimate goal here would be to somehow call this routine and have it shift up the screen with a macro. And so I'm going to set that up right now. I'm going to set up a new macro. So I would want to do it similar to this. Maybe shift, window, and then put in the X position, the Y position, the width, and the height. And so what that would do would call this sub down here, storing and shifting the screen up one position. So, or the window, that little window defined here. So let's create that macro on the fly right now. Define macro, shift window, and macro. So we want to load the first parameter and store it. If we're going to make it the X position, we're going to store it in win X. Load the second parameter and store it in win Y. Load the third parameter and store it in width. Load the fourth parameter and store it in height. And then do an RTS. Oh, actually, you don't do that in the macro. Excuse me. So that would be the entire macro, and that would define the window based on these parameters and shift it up one. We'll have to JSR. We do have to do the JSR. I need to give it a name. So JSR to I can't use shift window again. Scroll window up. Haul it like that. That should do it. Let's see if it compiles. And let's execute it. I made a mistake somewhere. Let's see. Let's see what I do wrong here. So what I realized I did was I made a very common mistake, and I forgot to put the hashtags in front of the parameters here. Otherwise it takes the literal value of the address 5, address 0, etc. And that was my mistake. Executing it now. You see now, yeah, so now it works. All we have to do is use the macro to define a window and to shift the position up vertically once. And so that's the first part of this exercise. Alright, so for the second part of this exercise, what I wanted to do was to take that window that it was just shifted up and then print some text on it. And that's what I've done here. Print some text on the bottom row. And so what I did was I took a copy of the window.asm, created a window2.asm, and then I went ahead and created a little print text program. And so what it does, at the very top, it sets the cursor position using this little kernel routine, E50A. You have the X position is the X register is your row and the Y is your column. So that positions it to the bottom left corner of the window. And then there's a loop right here. It loops through and prints the first however many characters that are in the string, which is defined right here, up until it hits the width of the window. Once it hits the width of the window, which is right here, it compares it to the width, then it scrolls the window up to make room for another line, and then it jumps back up and prints the next however many characters of text until it gets to the end of the text string. So down here, the string here is defined using the word null, and what null does is it zero terminates the string. So at the end of this string, it adds a 0 to the end of it. And that's how it knows, when this program here, branch if equal to 0, that's how it knows to exit the loop, right here. So let's take a look at that running. And right now, all that's in my string is the word this. And so each time it runs, it shifts the window up, it defines the window, which also shifts it up, and then it prints the word this at the bottom. So if I run it again, just puts the word this and scrolls it up. So let me add some more text to show you the wrapping. This, A, B, C, D, E. Let's run that. That's not going to wrap just yet. And so right here, that's the width of the entire almost the width of the entire window, I believe it is. And so if I put one more letter, it should show up on the next line. So let's add one more letter and run it. And so you see it scrolls it up. So when it goes to that next line, it scrolls it up, adds room for the next letter. Alright, so that's the first part of this. And I wanted to make this a little more usable by turning this into a macro to make it print other types of text other than just this same string right here over and over. Alright, so to do that, I'm going to take the variable out right here and just put in a fake address. Notice I have a label here, it's called main string. And here I'm just going to do str_north. And I'm going to make this print the word north. Like that. And we'll define a macro. Define a macro to print text. End macro. And I think how we want to call it is like this: print text and just put the variable name str_north. And then just put the high byte and the low byte. LDA hashtag less than. We'll get the low byte, store it in main string +1. And then the high byte is stored in +2. And that should be all we need for that macro. Let's see if it compiles. And let's see if it runs. And there it is. So now it prints north and scrolls it up. So with that, we could have it print whatever text is using this macro. I can define a bunch of variables and have it print north, south, east, west. Alright, before getting too far into the next integration segment here, I wanted to go ahead and point out that one of the YouTubers sent me an idea which I put into place here, and that was Kelly Halliburton, and she came up with this code combination for the water. Remember last week I was looking at different water combinations, so I copied and pasted that in the program, and let's look at what Kelly came up with. And so I thought that was cool. It kind of looks like it could be a wave going through, the water shifting up. Okay, so now the next part is to integrate the window code into this program, and to do that, I'm not even going to modify Zef3, I'm going to make a copy of it, and let's create a Zef4. And then I'm going to grab code, all the macros, and throw them into the macro section. See if it compiles. Good. Then I'm going to grab the code, scroll window up, display text and the variables, and throw it near the bottom of the program. Actually, right before we redefine the character set. copy the comment. And before we go any further, let's compile. We have a few errors, duplicate labels. So input SCR, output SCR, input SCR. I know I could do a search and replace, but I find this easier. Output SCR. The loop up here is duplicated. Compile again. I don't have my variables. Let's pull in these variables here near the bottom. Should probably move those. Let's bring them in right there. Compile. Now I'm not calling it yet, so it's still the old program, just brought in the new code. So now let's call it. So to do that, I want to copy these two lines and then put that in as where it does the keyboard input. So like up, down right here. So I think right after this, if we shift the window, but we got to find a new location for that window. You got to at least move it down a little bit, and that's what I've done already. So 5, 15, 10, 5. So X characters over horizontally, 15 characters down, 10 characters wide, 5 characters deep. Print the string north. That should print north, north, north every time I push down. Oh, we got an error. I just got to move this up. So if I push down, north, north, north. And if I just repeat for east, west, south, north, I should have a little window there. Let's try that. So let's redefine some strings. Let's put some new ones down there. North, south, east, west. Oops, that didn't work. North, south, east, west. And then just change the subs here. I don't like that I have to call that shift window every time, but I'm not gonna worry about that right now. So this would be south. This would be east, I'm assuming, and west. And that's easy to switch around if I got that backwards. Let's test that out. Let's see what we got here. We're running into invalid branches. Bummer. Because these are macros when they expand out. I can't go beyond 126. So we got what, move up. Just to get it running, I'm just going to branch it down to underscore move up. And let's see if that works. North, south, east. That's west actually, huh? And that's east. So I got east, west backwards. That's easy enough. West, east. West, east, no, south, north. So that's kind of where I was heading with this for today's video here, but now all I have to do after this is incorporate the border around this to bring it all together. But this is enough for now. This is enough for now, right now. I'm excited to have at least gotten this far, so.